Mrs. D here. We're going to look at solving simple exponential equations, and they should be pretty simple. Straightforward, that is, once you kind of figure this out. To start here, we're going to talk about the idea of equivalence, and we've been doing this a little bit. But in order for two exponential expressions to be equal, when we're looking at their form, a times b to the x, c times d to the x, then the only way that they will be equal is if they have equivalent bases and equivalent initial values. And I kind of said that backwards. But we're basically saying that these leading numbers need to be equivalent. Now, they might look different, but if they're equal in value, maybe not in appearance, but in value, then they will be equal. So we would like to get the same base and the same exponent. So sometimes if the base is a little bit different, the exponent is a little bit different, then they are in fact equal, even though they don't appear to be, like in our first example here. But if you do some manipulation, then you'll see that they are in fact equal, or at least for certain values of x, they will be equal. So right now I'm noticing in this first example I have a base of 1/2 and a base of 1/4, which are definitely not the same. So if I tried to, I could get them to both have a base of 1/2, or even both have a base of 2. So I will not change the first side of the equation, but I will rewrite 1/4 as 1/2 squared. Now that looks a lot easier to solve, believe it or not, because I already have equivalence with the 1/2 base, and then I can simply look at the exponents and say, well, if these are going to be equal expressions, the only way that will happen is if the exponents are equal. Simply multiply by 3 on both sides there, and you have x equals 6, which is the solution. You could get a base of 2 on both of these. That could work as well. 1/2 is 2 to the negative 1. So just another way to do this. And 1/4 is 2 to the negative 2. Turns out you're going to get the same answer, because here we'll have negative x over 3 equals negative 2. Either way you do it, you're going to end with an answer of x equals 6. You could always check that, plug it back in, 1/2 to the 2. Look at that, it is 1/4. So we have an answer that works. Two more examples here to look at. And the first one maybe looks a little more complicated. That's how I do my examples, if you haven't noticed. They do appear to be more complicated as we go on. What should we do first? Well, try to get the same base. You can't really do that at all with a 3 and a 5. And what in the world is that 45 doing? So let's do some algebraic solving here with that 45. Start to isolate your exponential part of the equation. So get that 3 to the x plus 2 alone. And when you take 5 divided by 45, it's going to reduce to 1/9. So simplifying at first here helps us quite a bit to see what these two sides are made of. And I could write them both now as a base of 3. 1/9 is 3 to the negative 2. And with similar or equal bases rather, we now just have to say, hey, make those exponents equal. Then these expressions will in fact be equal. Subtract 2, and x equals negative 4. Solution. Now you can always be checking these solutions by plugging them back into the original and making sure that it works out. Let's just do that real quick with this one. Is 45 times 3 to the negative 4 would make that a negative 2 power equal to 5, question mark? Well, is 45 times 1/9 5? Yes, it is. This last example has a number of different bases, especially with a fraction as a base. You got to think about what each numerator and denominator are made of. So 9 could be brought back to a base of 3, 16 could be brought back to a base of 4, and we can do the same thing with the 64 and the 27, and so that's what we're going to do. We're going to start by rewriting 9 as 3 squared, 16 as 4 squared. We'll worry about the exponents in a second. And 64 is actually 4 cubed. 27 likewise is 3 cubed. And if I try to solve from here, I'm going to write this now as not two separate bases, but one fractional base, meaning this is going to be 3/4